Hello, my dear student. Today we are in lecture 39. Lecture 39 of chapter 3 NCERT. Current electricity. I am S Pandey. My dear student, as I told you in last lecture yesterday that we will start this lecture 39, that is the today's lecture, with the plot of terminal voltage and current. Okay, this was the battery or the cell, the internal resistance. It is connected with a load resistance and a current flowing through the circuit. It is I, it is E, R, and this is the capital R. This terminal A and B. Actually, we used to say this VAB as the terminal voltage. Okay, so we are going to plot the graph, plot of terminal voltage, you can say here the VAB versus output current. Okay, output current by the circuit. What will be the nature of that output current? Okay, so could you write the equation, my dear student, for the current here? So it will be E is equals to IR plus IR, and thus IR can be written as E minus IR, and this is nothing but the terminal voltage V. Okay, this is the terminal voltage E minus IR. If we will take, this is on y-axis and this is constant, you know, if this constant is represented by C, and this will be considered on the x-axis. Okay, my dear student, then we can equate this equation by the straight line, equation of a straight line, and it is y is equals to C minus mx. Could you compare this with the equation of a straight line? Here y is the voltage, if this is the graph, y-axis, and this is the x-axis. On x-axis what we are using? On x-axis we are using output current. On y-axis we are using terminal voltage. Okay, on y-axis we are using terminal voltage, and here we are using current in ampere. Okay, so what will be the graph? You can see even at zero current, if current is zero, whether this value of VAB, that is on y-axis, is zero, answer is no. It is E, and this E will be the maximum value. Suppose this is the E. Okay, this is the E. When we are getting E, when I is 0. As this I will increase, what will happen? As this I will increase, this amount will decrease, but linearly, because this is the straight line. So graph will be in this way. Okay, this is the straight line. And this is the plot of terminal voltage and output current. Remember, my dear student, whenever you are required to find the EMF of the cell, then this value at zero current, this value will be, the voltage will be at 0 at I equals to 0. Okay, the V is EMF. Remember, you will be asked several questions, numerical. Now, about the internal resistance, you can see over here, this M is nothing but the R. It means R is slope. Internal resistance can be obtained by the slope. Okay, slope of V versus I. But remember, this R will be the equivalent R. If you are drawing the plot for one cell, then of course here you can find out. But if number of cells are connected in series or parallel and you are getting the slope, then this will be the equivalent resistance. Remember, this is the R equivalent. For what? For number or for grouping of cell. For grouping of cell. Remember, for single cell it is very good, it is the slope, and the slope by tan theta you can calculate. It is not very tough. The tan theta will give you the slope. It is the tan theta, it is the perpendicular by base. It means this theta will give you the slope. Okay, my dear student. So in this way you can find out the internal resistance and EMF of cell. The number of questions I have given in my assignment, you can see, you can solve the assignment. But today we will discuss few more questions after the combination of cell. Okay, so we are moving to the next topic. It is the combination of cell, my dear student. Kindly note down, write down the next topic. It is combination of cell. Okay, it is combination of cell. So two types of combination we will study. The first, series combination. Okay, the series one. Suppose we are having here the cell with internal resistance, another cell with internal resistance. Only two cell we are studying here. It is connected with a load resistance. Okay, what is the aim of combination? Aim of combination to find a substitute one cell behalf of number of cell. If it is E1 internal resistance R1, it is E2 internal resistance R2, and it is load resistance R, then we can use one cell. Okay, and it is also connected with the same load resistance. Now this will be the equivalent, this will be the R equivalent, and this is the R. Okay, and this is the terminal. Suppose if both are connected in series, what will be the current? So the current will be same. Here I, it means this equivalent will also leave the current. How much? It is I. Okay, I'm sure that there is no any confusion between this all. Now we can write, my dear student, here as this voltage across this entire network, that is the you can write here using Kirchhoff's law, I R in direction of flowing of current we are going, plus here the I R2 plus I, next we meet with the cell, so minus E2 plus I R1 minus E1 is equals to how much? 0. Now we can equate this one as E1 plus E2 is equals to I R plus I R1 plus R2. Am I right, my dear student? Yes, we can write. Suppose this is equation 1. Now for equivalent circuit, look at here, it is IR plus IR equivalent minus E equivalent is equals to 0, or E equivalent is equals to, you can write IR plus IR equivalent. Okay, the equation 2. Now you can compare equation 1 and 2, since both are the similar, because we have taken here the identical. Okay, so both are similar. So comparing 1 and 2, equation 1 and 2, we can see here in this equation E equivalent is equals to E1 plus E2. So the E equivalent will be E1 plus E2. In case of series, the equivalent EMF will be this one. Now the second thing, if this is terminal voltage, this is also terminal voltage, then plus, then we are having plus. Now I, then we have I. It means R equivalent equals the R1 plus R2. R equivalent equals to R1 plus R2. Okay, so this is the equivalent EMF in case of series combination. If n number of cell you will connect, you will find E equivalent equals to E1 plus E2 plus and so on. Okay, my dear student. Now, could you find the current also? Yes, we can find the current. What will be the current? So the current will be E equivalent divided by R equivalent plus R. Okay, from here you can find out the current also. From here you can find out the current. It is R, I is common, so R plus R equivalent, so E equivalent divided by R plus R equivalent, and this is the current. So in this way you can find out in series combination the current and all the things, my dear student. Now we are moving for the parallel combination, but before that parallel combination, if a question in your mind, my dear students, are coming that, sir, what will be the equivalent EMF or the internal resistance or the total current if we'll flip one cell? Okay, if we will flip one cell, its negative term will be taken here and positive over here, then what will be the all physical quantity? Okay, let's check. If the circuit looks like this one, if you flipped, okay, this was the question. Yes, E1 R1, R2 E2, and the external load resistance is the same, then what will happen? So listen carefully and look at here, my dear student. If you will flipped this particular any one cell, first you will have to see which one is the mother cell. Okay, if E1 is greater than E2, then current will start moving in this direction. Okay, sorry, I. If this one is the mother cell, it means if EMF E2 is greater than E1, then current will move from this side. This is the difference in the direction of current. First thing. Second thing, if this is flipped, then what will be the equation you will get? Actually, you will get the equation. This is the IR, no changes. Here IR2, no changes. Here IR1, no changes. Here minus E1 was there. Try to recall minus, or if you have written over your notes, try to see it is minus. Only you are getting here the plus E2. Plus E2. It means only the equivalent will change and it will be E1 minus E2. And R equivalent is not going to be changed. It will be the remain same. How much it is? So it will be R1 plus R2. And the total resistance of the network will be also same. The total current will change. The total current now it will be E1 minus E2 divided by R equivalent plus R. Okay. So this type of analysis should be comes in your mind, my dear students. Now the next one we are going to study here, the parallel combination. If we combine the cell, okay, we combine cell in parallel, then what will happen? Okay, so the second one is the parallel combination. Parallel combination. So first we will draw circuit. We are using this space because the circuit will be a little larger. Another cell, and it is connected with load resistance R, R2, E2, E1, R1. What will happen? This cell will leave the current I1 and this is I2. This is the simplest way I am telling you for the derivation. Otherwise you can take only one current from one cell, or by deciding the mother cell also. This is the very simplest one. It is mentioned in your NCERT. This is I1 and this is I2, and the network will receive the total current I. Okay. What we have to do, my dear student? Actually we have to get a equivalent circuit. And this is the equivalent circuit connected with the load resistance. It is E equivalent, R equivalent, and this is load resistance, the terminal A and B, etc. Now we are going to proceed we know that this I will be equals to I1 plus I2, no doubt. Now, suppose this is the terminal A and this is the terminal B. Okay. What will the potential across this particular two terminal? So the potential over here will be E minus IR. Here the total potential will be the potential, that is the EMF minus the potential which is dropped over here. If it is 1.5 volt and here dropped 5.5 volt, the total potential will be how much? 1 volt. It means we can write here the potential difference VAB is E minus IR, and so we can write here the VAB for which cell? E1. For E1 we can write VAB, it is E1 minus I1 R1. Any problem? No. It is E1 minus I1 R1. Similarly, for E2, what you can write? VAB again, because this two terminal also connected over here. So the VAB, it is E2 minus I2 R2. Okay. E2 minus I2 R2. For this equivalent, what you can write? You can write VAB, it is equals to E equivalent minus I R equivalent. The very simple. Okay. Now try to find out the I1, I2 and I from these three equation. Okay. This will be your three equation. 1, 2 and 3. Try to find out I1 and I2 and put in this one. I is equals to I1 plus I2. So from here I will be, you can see it is I is equals to E equivalent minus VAB, say it is VAB, we are writing VAB as V. Okay. So the V divided by R equivalent. In similar way, I1 will be how much? So from here the I1 will be V E minus V divided by R1, and I2 will be E minus V, sorry, here E1 and E2 divided by R2. Now we have another three equations and we will put these three equations, okay, in I1, I2, I3. So what will be the equation? And the equation will be I, that is E equivalent minus V over R equivalent is equals to I1 plus I2, that is E1 minus V by R1 plus E2 minus V by R2. Now we are going to simplify this one. Kindly note down, I am rubbing this. Okay. Let me rub this one also. Okay. Now this can be written as E equivalent by R equivalent. E equivalent by R equivalent minus V by R equivalent, or V times 1 by R equivalent, is equals to here E1 by R1 plus E2 by R2, E1 by R1 plus E2 by R2 minus you will get in both the equation V by R1 minus V by R2. So minus will be taken. So it is V times 1 by R1 plus 1 by R2. Okay. I hope there is no any confusion. Now we will compare this LHS and RHS, left hand side and right hand side. So you will see the left hand side comparing LHS and RHS, my dear student, you can see E equivalent by R equivalent. It is equals to E1 by R1 plus E2 by R2, and 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Okay, so this is the equivalent resistance and this is the equivalent EMF by equivalent resistance. Now student, you can write the equivalent EMF only. It is R equivalent times E1 by R1 plus E2 by R2. The very simple equation. Okay, so this is the E equivalent. Now my dear student, could you write the current also? The answer is yes, we can write the current also. So what will be the current here? So you will write the current as I is equals to E total by R total. What is R total? So the R total of the circuit is for the equivalent resistance. Here you are getting plus there was in total equivalent circuit there was a resistance in series also, na? So it is R equivalent plus R. I hope you are getting. And then I will be, and what is E total? So E total is equivalent. E equivalent by R equivalent plus R. This is the current in the network. So this is the parallel combination, my dear student. Can you note down here? Now we will solve a simple question and then we will proceed for the next, that is the mixed combination. Okay. So one question, we are in lecture, in this lecture, and the next question. Here student, I am going to give you a question as you can say the classwork for the using the concept of plot of terminal voltage and current. The question is 4 identical cell of EMF E. Okay, how many cell? 4 cell. Each having EMF E and internal resistance R are connected in series. Okay, they are connected in series. Then it is given a variable resistor is connected with the series and graph represent terminal voltage versus output current. You have to find it is EMF. What will the EMF of each cell? Remember, you have to find the EMF of each cell. The graph is representing the equivalent, but you have to find the EMF of each cell. The second, you have to find the internal resistance of each cell. And the C, which is the very important, you have to find the maximum current. Okay, what will be the maximum current in the circuit? For this maximum current, student, I will teach you one topic. Okay, it is the maximum power theorem. But before that theorem, you can solve these two questions. I will teach you right now the maximum power theorem after solving these two questions. Okay, so you can solve that is also, or I will give you the small concept. Now the graph. This is the graph between the terminal voltage it is 0, 0.5, 1, 1.5 and the 2, it is in ampere. Okay, here 1.4, it is the 2.8, it is 4.2 and it is 5.6. Okay, it is in volt. It is given, and the graph is like this one. This is the graph, and you have to find these 4 things. How we will solve? Okay, so one by one I am solving the first question. As we know that we have to find the EMF. How many cells are connected in series? 4 cells. Okay, so the E equivalent, we can write the 4 times E if identical cells are connected, and at I equals to 0, we know that the potential difference, if it is the potential difference is the EMF. It means at 0 you can see the potential difference is how much? It is 5.6. It means this is 4E, which is equals to the 5.6 volt. It means EMF of one cell will be 5.6 by 4 and 1.4 volt. Okay, my dear student. So 1.4 volt is the EMF of one cell. Now B, internal resistance. So we have studied the internal resistance, nothing but the slope. Internal resistance. So suppose R equivalent is the slope. I told you, na, if this graph is represented for one cell, then R equivalent will be the R internal, that is 1 for one cell. But here the 4 cells are connected. That's why the R equivalent will be the slope. And what is the slope? So the perpendicular by base. Here the perpendicular for 5.6 and the base is 2. It is 2.8 ohm. But this is R equivalent, and the 4 cells are connected in series. It means the R equivalent will be also 4 times R, and it is 2.8. For one cell, the internal resistance will be how much? 2.8 by 4. Okay, that is 0.7 ohm. Now the maximum current. Okay, so for maximum current, my dear student, I am explaining here. Can you note down this one? I am rubbing this one. The maximum power theorem. You need to just remember maximum power theorem. We will study in detail, but maximum power theorem you do have to study in standard 12th. Actually, in graduation you will study this maximum power theorem. It is called the maximum power reciprocity theorem, and this will help to find the maximum current. Even you can find over here also in standard 12th maximum power theorem. If it is the circuit, look at here carefully, with the load resistance R, internal resistance, and the EMF. So for I max, remember internal resistance or the external load, external resistance should be equals to the net internal resistance. Net internal resistance. This is very, very important, my dear student. I will be maximum, that is the power maximum, when the external resistance, that is R, is equals to the R equivalent, that is the net internal resistance. Here only one resistor is connected in the question. What will be the current? So the I maximum, it is I is E by R. Okay, E by R plus R, that is the E net equivalent by R equivalent plus R. Okay, now I is equals to E equivalent. What was the value of E equivalent? We have calculated already, and the R load resistance should be equals to this one. So we are having the value of this one also, and E equivalent we have calculated at the 5.6. Okay, however I remember it was the 5.6. 6 divided by R equivalent plus R equivalent. It means the twice of R equivalent. And what was the R equivalent? That is, it was the 2.8 for 4 cell. For 1 cell we have calculated the 0.7. Okay, and it will be 1. So the 1 ampere is the maximum current, and this is the concept using the maximum power theorem, my dear student. Okay, so here we have solved a few question of combination of the combination, even the graph questions also. Okay, now one question I'm giving you for the homework, my dear student, and in next class we'll study the mix combination. Okay, the mix combination. Okay, the one homework I'm giving you for the today lecture, and we will also study in next class this particular question. I will teach you how you can solve. So this is your homework. Using current distribution that I will teach you in next class. Just I'm giving you homework. If you can solve, it would be very nice. The 4 volt, the 2 ohm, here the 8 ohm, here the 4 ohm, here the okay, take another resistance. It is 6 ohm, and this is 6 volt. Okay, and this is 1 ohm. You have to find current and voltage across each resistor. Okay, find current and voltage across each resistor. Okay, my dear student. So we are concluding today's lecture with this homework, and this is all about today's lecture, my dear students. Thank you very much.